You had questions to Mrs. Steele about why Mount Vesuvius in Pompeii exploded without lava. Now, the reason it did so is because it's what's referred to as a pyroclastic flow eruption. The important thing to remember is that all different types of volcanoes can typically not only come in different sizes and shapes, but have very different types of eruptions with them. So if we look here, you can see different types of fissures and cone shapes that cause different types of eruptions. And they can look quite different. You have things like a shield volcano, a caldera volcano, which effectively looks like a mountain that's blown off its top. Crater Lake, Mount Mazama, is what we refer to as a caldera type volcano. A stratovolcano, that's the most common and iconic type of volcano that you'll see a lot of the Hawaiian volcanoes look like that. Soma volcanoes are a caldera type volcano that has another small mountaintop breaching from the middle. And then compound volcanoes like the Three Sisters in eastern Oregon. So here we can see different types of eruptions as well. You have Icelandic eruptions. That's usually where two tectonic plates are moving away from each other, and then lava comes through the fissure in the ground. A Pompeii eruption is something very similar to what happened on Pompeii. But here you can see there's a lot of magma. So again, you're asking yourselves, why did it erupt without magma? And again, the reason is because it's what's referred to, as a pyroclastic flow eruption. So what happened? You had your magma chamber, you have cracks and fissures in the ground, and a conduit leading up. And that's how all the pressure built inside the mountain. But what happened was, as these fissures got all the way to the surface, there was enough pressure built up, there were enough gases built up, that it actually blew part of the mountain off of the top of the volcano without releasing the magma chamber. So the magma chamber itself built and built and built, and then there was enough oil or pressure and gas that it just erupted down the side. And what that means effectively is that the gases were so hot and so powerful that it liquefied or destroyed all of the surface parts of the volcano, reducing them into ash and rubble effectively. Now, what you'll note is that is so hot and so expansive that it melts any ice or glaciers that are on there, and it turns that water and those gases and along with that ash into an effective avalanche of ash and dirt and grime and rocks. So what happened was, as it erupted, it shot, you see this eruption column, all this stuff into the sky. And as eventually gravity re-overtook the weight of the objects, they fell back down to Earth. Largest particles first, what you saw in that video, of rocks and things hitting the town below, and then soon all the finer particulates, the ash and the heavy matter. Now, sometimes you can have a volcano that erupts so catastrophically, it will vaporize or atomize that ash and will send it so high into the stratosphere that it will stay there for years. In fact, there's an event called it was called the mini ice age, where Krakatoa exploded. Krakatoa is a small island in the Pacific Islands. There was a small volcano in the Pacific Islands that erupted so catastrophically that it actually threw enough ash and dust and dirt into the sky that it blanketed the Earth for almost 2 years, throwing North Europe into a mini ice age, a mini glaciarization, because it blocked out all of the sun. So it still doesn't answer the question, what happened to the magma? Well, the magma didn't rupture. It didn't make it all the way to the top. It built and built and built, and then once it released all of that pressure and it threw everything into the sky, the pressure was released and the magma stayed in its chamber. And then the volcano, did its thing. It shot all the gravel and the rubble, all the things that were holding the pressure inside. It released it, and therefore it didn't need to breach the magma chamber. It's a very rare circumstance, but it has happened. In fact, within many of your parents' lifetimes, Mount St. Helens erupted, and it was a pyroclastic flow. And what it did is it went from a shield volcano like Mount Hood, and it literally just blew half of the side of the mountain off. And the mountain has remained the same ever since. And there was no magma, and there still is no magma. because the magma chamber actually never got close enough to the surface to breach. So, but what it did do is it's so hot and it produced all these gases and all these very, very intense heats that eventually just built in the top of the cone, and then it just got too hot and it found a way out through a fissure in the ground, similar to you see here, and just blew half the mountain out. The really scary thing about pyroclastic flow over a lava flow, like you'll see in Hawaiian videos, is actually pyroclastic flow. The temperatures can reach 1,000 degrees Celsius or 1,800 degrees Fahrenheit. It will also can move at about 65 miles an hour down the mountain, but it's been known to reach speeds of 450 miles an hour down the mountain. For reference, the fastest a human being has gone on a motorbike is 250 miles an hour, and the fastest a person has ever gone in a motorized vehicle is somewhere around 350 miles an hour. So there was no way to outrun it. So that's why there was no magma. Thanks, kids.